All right, welcome everybody. This is the Robotics Colloquium, and I'm excited to introduce Professor Fumihide Tanaka. I've gotten his first name wrong many times, so he made a point to tell me that in the US he had the nickname Boom. Is that right?
Yes, it's funny, but someone calls me Boom. Yeah.
So he's had a long journey to become a professor at Tsukuba. He had positions in Sony, Tokyo Institute of Technology, Sony Intelligent Dynamics Laboratories, UC San Diego, University of Tokyo, and then finally Tsukuba. We have known each other for a long time. He's a very well-known person in the HRI community, and I remember being at a talk, as I think one of his iconic works was this educational robot that was, instead of being a teacher robot, was pretending to be a student robot, so pretending to not know something so that the kids could step in and become a teacher and learn in the process of teaching the robot, which my HRI class actually read this year. But you might know that there is an initiative for collaborations between UW and Tsukuba. So he's visiting for that purpose, and we're working on a grant. I'm really excited to start collaborations with him. We actually had a talk canceled because the speaker had to go to Japan, and it was a really great coincidence that Professor Tanaka was visiting from Japan to fill in. But he's going to talk about a lot of different research at his university, and then he's going to be around afterwards if you want to talk about your XPAI proposals that you're working on and want connections. He's been very generous to get people connected to other researchers there. With that, I'll give it.
Great, thank you, Maya. So maybe I don't have to use this microphone because I have this one, right? Okay, great. Okay, so thank you for introduction, and again, nice to meet you, everyone. And maybe I just I didn't expect to talk this, but the reason why some people call me Boom is because can I write on this? Yes. Yeah, by using this. Okay, you know, this is my. You know, every Japanese has its own. I mean, Chinese character expression. This is how my name is written in Chinese characters. So this is Tanaka, that's my last name, and this goes Fumihide, maybe. This is extremely difficult to pronounce. Even I sometimes, you know, it's difficult to say, but it reads Fumihide. Fumihide, Fumihide in English. And, you know, this Chinese character corresponds to the pronunciation of Fumi, and this Hide. And you know, this is why the Japanese is so difficult to learn. But every Chinese character has multiple, totally different pronunciations. So one pronunciation is Fumi, but the other pronunciation Boom. so that's why, you know, the Japanese, the States who live in here but know the very deep knowledge of Japanese calls me Boom. So this is weird but easy to pronounce. Anyway, so that's no, this is I don't have eraser. Okay, I will leave this. What it is. So. Going back to the myself introduction. So first of all, I'm very happy to be here. And although I just arrived the day before yesterday, you know, in last 24 hours, I think I had enjoyed the, you know, amazing amount of talks, starting with discussion with Meyer and Nick's thesis defense, and I even had the opportunity to attend the HRI class yesterday, and I am now fully enjoy the University of Washington here. Okay, so as Meyer kindly explained, so this is kind of my history, my background, and. After I got my Ph.D. in the field of reinforcement learning, I'm almost forgetting about that, but in Tokyo Institute of Technology, And I first joined the Sony Corporation in Japan. And maybe some people, I hope, knows, but Sony used to did this entertainment robots researches, and like a dog-like robot called the Aibo. I think it's still there. The newer generation Aibo is still there. And also there on the right side, there is this small humanoid robot. It's called the Curio, but it's, I think, one of the earliest humanoid droid, like Honda's Ashimo, and also Sony had this small size humanoid robot called the Curio. And then I also had a nice opportunity to stay at the UC San Diego for 3 years. And I think it was the time when I started the researches of this human-robot interaction. So in fact, the SEM HRI conference started in 2006, I guess, in Salt Lake City. And believe or not, I gave a talk at the first day of the first session after the amazing plenary talk by the Clifford Nass in the Stanford. That was amazing, right? But I gave just a regular talk after Cliff Nass, and it was 2006. And then, since then, I have been working in this human-robot interaction, and in our case, particularly the younger generation, like those eventually they are toddlers, younger than, I think, 24 years old. And then, yes, it was 2008, I guess, actually. Unfortunately, the Sony's business was becoming very bad, and they decided to discontinue the researches of robotics and AI. We cannot believe now, but at that time the business was very, very bad, really bad. So 2008, they discontinued this business, and then I moved to the academia. And yes, and I first was affiliated with the University of Tokyo. And since 10 years ago, I have been here. I have been my current affiliation, which is the Tsukuba, University of Tsukuba. And basically, I have been working in the field of, I guess, social robots. And also, I may add another thing. So it was 2014 or 13 when the SoftBank released this Pepper robot. Now everyone is forgetting the Pepper, but Pepper was released in 2014. And at that time I was in the University of Tokyo, but I had a dual contact with SoftBank. And I was serving as a consultant of the release and the development and the release of this Pepper robot. I worked at SoftBank for 2 years as a consultant. Okay. And anyway, so the reason today I'm here is, first of all, as Maya said, there is this great opportunity called the Cross-Pacific AI Initiative. We call just XPI. And so yesterday, we discussed the future collaborations. But not just this, but by taking these opportunities, I'm more than happy to, connect both universities. So from now on, I will introduce some robotics research work done in our universities. So if some of you has an interest of collaborating with them, just please don't hesitate asking me, And I'm very happy to introduce them to you. And I'm very happy to connect the UW and the University of Tsukuba. So that's my motivation of the coming here. So probably in the first half of my talk today, I will introduce the University of Tsukuba a little bit. So first of all, where is it, Tsukuba? So Tsukuba is located in the north part of Tokyo. It's in an hour from the central downtown Tokyo by train. Is there anyone who had a chance to go to Tsukuba? No, right. But it's just not that far from that Tokyo. And this is one of the national university, like Tokyo and Kyoto. And one of the significant characteristics of this University of Tsukuba is that our university covers a really wide range of areas, so including physical education and the sports sciences. So in fact, in our universities, we produce a number of Olympic medalists. So this is probably one of the characteristics of our university, because other national universities like Tokyo, Kyoto, they don't have these kinds of sports sciences and the arts. So in Japan, usually the arts is the university for arts is completely separated from the university and the other areas. But our university has the department of the arts as well. So maybe I should say one of the characteristics of our university is to, continuously doing a wide range of collaboration researches, including those areas. So actually, some researchers, some faculty members in the robotics area is doing collaborative research between those sports science and even the arts. And also, I think our university, and we are very active in the robotics research as well. My personal guess is that it's ranked in the top 3 or 4 in Japan in robotics area. Okay, so then from now on, I will just introducing some robotics research in our universities. So this is the so I think this is this is almost impossible to read. So I just change this. This is a research of exoskeleton robot, and by sensing this, by going for biological surface electrode, and then just maybe you are familiar with this, and this is one of the most established research in our universities, the exoskeleton robot, and it's already commercialized and on market in worldwide. And this is just for lower limb type. And they even have this single joint type on the elbow and the knees. Okay, so this is a.
Was the company spun out of the lab?
Mm-hmm. Yes. So this company called Cyberdyne is spin out from the. Sorry, this is too difficult to read. The laboratory is called the Cybernetics Laboratory directed by the Professor Sankai, Yoshiyuki Sankai. So the upper left. So he retired our university last year, but still he continued the research and development of his own company. So he has been long doing the researches of this exoskeleton robot, and also did many trials, and even the clinical trials. And after finishing these clinical trials, he produced the product, and he put it on the market. So this is the first example of our robotics research group. And then what's next? So this is also the robotics related research, but we also have the researches in the field of robot manipulations. And the first professor on this slide here is Professor Aiyama. And I guess you guys know better than me. And to be honest, I'm not so familiar with the detail. But if you have a, impression that you are interested in, you want to talk with those person, just don't hesitate asking me, and I will introduce them to you to discuss the more details. Right, and yes, and this Professor Aiyama recently has been doing researches of utilizing virtual reality, and he actively collaborates with the Japanese industries as well. Okay. So it seems like this is some manipulation robot just focusing on the precision work in aerospace by teleoperation. And next, so this is a slide for Professor Nakauchi. And he has been doing work of the, what he called as the intelligent environment, using robot and sensing technology, probably IoT. And but in addition to this, I think one of the greatest achievement of his lab is this underwater drones. It's completely different. But this company is also, there is a company spin out from the lab. And this is now in Japan, I guess one of the most advanced startups in Japan in the area of these underwater drones. Okay. And next, again, this is related with motion control and manipulation. But Professor Sakaino is a very active young researcher and working in the field of robotics. And his main research interest is this bilateral control. Yes, so bilateral control-based imitation learning for position force hybrid motion generations. And he also has been showing several demonstrations, and recently, in particular, he's trying to deal with food. And he always insists that their system is very fast and adaptive. So it seems like this is a co-manipulation with the human workers. Okay. And the next, so this is a laboratory directed by Professor Yamaguchi. He's also a young professor in our department. And he has been doing the research of this robotics for inspection, maintenance, those facilities. and by using drones and other types of robots. Okay. And last, not but the least, and this is a slice given from Professor Mochiyama. And he has been doing research in soft robotics. And his lab is called the Flexible Robotics Lab. And this one, I forgot the name. There is a name of an animal, maybe ostrich? Do you know ostrich? Ostrich. So yes. So this is clearly the under-actuated, very redundant motion control. He tries to control the neck part of this ostrich, and also he has been working on this what is called flat spring, maybe flat spring. This, so somehow he very hooked on this, the use of a flat spring, and he has been utilizing this flat spring in a jumping robot or other funny soft robots. Okay, and also one of his main research interests is how to control those extremely complex and under-actuated systems. And the recent work just published in ICRA or IROS last year is that he utilizes this old, what's called as a rod theory to solve this under-actuated problem. Okay, so anyway, so those are the quick introduction of the our robotics laboratories. And so I'm sorry that I'm not familiar with the details, and maybe my explanation was not good. But just as I have been repeatedly saying that if you have interest in some part of that, I'm very always happy to introducing them to you.
Would it be possible to share a PDF of the slides? That
Yes,
would be great.
yes.
Thank you.
Yes, of course, yes. Okay. All right, and then maybe I will switch to the latter half of my talk. And from now on, I'm going to explain some of our research we did so far. And yes, and as Maya said, that in the past, I have been working in the field of child-robot interaction, and also the application of robotics for the purpose of supporting their education. So I will quickly explain those old projects. So I have to remember myself because it is almost 20 years ago. And yeah, so if my memory is correct, I was in UC San Diego in early 2000s. And this is a very funny project, but now I cannot believe. But I stayed in the nursery school of UC San Diego for 3 years, and I just focused on taking care of the kids, and I spent purely in observation for the first year, and then from the second year I finally started my research experiments. Now I really cannot believe it. So, and then the last year I spent, data analysis. You know that the video coding, those kinds of things really takes time. And but anyway, at that time I was an employee of Sony Corporation still. So this is a collaborative research project between Sony and the UCSD. So as an engineer of Sony Corporation, as you know, Sony is an entertainment company. So our goal is to create this entertainment system. This is an extremely difficult task. So our approach is as follows. So through conducting this exploratory field study, and we want to explore, we want to find any clue, any hints to attract their interest for a long time. Because as you know, that kids' interest switches extremely fast, and they don't care how much this robot costs and those kinds of things. So that's why we thought that, although kids is extremely tough customers, but it might be a really great opportunity for us to find really important elements to create the entertainment products. So that's why we did this kind of funny exploratory study. So maybe before switching this slide, I will show you a couple of videos. Okay. Lodging this race. Okay.
Julia has come. Good morning.
Okay, sorry. That's not a joke. So we seriously did that for every day. So believe or not, I commuted there every day as if I were the parents of the robots. And we seriously did that. And we seriously acted. And that was an early childhood education center in the UC San Diego. And the classroom was an infant class, and they were younger than 24 years old. So, as you know, that in the morning we just, put the robot and say, hey, that is going to work. And then, actually, I will sneak into the back room. Maybe you can see that, oh, yes. So as you can see the window, so there is a back room. So this is a typical classroom environment in the UCSD. And I was sneaking into the back room and did the observation. And sometimes I remote control this robot. And completely this is a exploratory study. So my goal is try to keep their interest as long as possible. Because in this classroom environment, there are bunches of competitors like TV or Pokemon or whatever. So I really have to beat them and to to control this robot and attract their interest. So this is, I think, the video taken at the soccer time.
No, it's a song, but they changed the words.
That's funny. So, yeah.
I wonder if they remember.
Yes, actually, the sociologist always, even nowadays, they sometimes send an email that you should do follow-up study to to interview them.
Nightmares about robots.
Yeah. So, yes, please.
How many robots did they break at the end?
Oh, that's a great question. So, the answer is 0. So this is what I really was impressed. So the power of major industry. So you know that our robot we created at the University of Tsukuba, it's very easy to break, right, as you can guess. But this robot, made by the great Japanese industry, Sony, they put a huge amount of money, huge amount of human resources to create this robot. And surprisingly, through these 3 years project, it never broken. And at one point, I counted the number of the robot robot fall downs, and it turned out that the robot fell down more than 50 times, but it's still kept moving. So I was very, very impressed at that. And there are bunches of, as you can guess, there are bunches of results. But here today, due to the time, I just showed you only one result. Maybe this is one of the most important results. And we just found that we had quantitative data showing that the kids go to treat the robot in a way they treated each other. So just simply speaking, we did a haptic coding, and we compared the behavior of, child-robot interaction versus child-child interaction. And it turned out that through this, and we kept going there more than almost 6 months. And through this long-term interaction, so we had quantitative data showing that kids gradually go to treat the robots in the way they treated each other. Maybe, and also, yes, so this is a video I played frequently at that time, so some of you might have seen this before. But this is one of the typical, example showing that how kids treated the robot. So maybe before playing this video, I have to explain a little bit. So on that day, I was testing this dancing application of the robot made by Sony, but unexpected things happened, which is the battery of the robot was running out. But again, so this is a great invention of a Japanese company, and they put a great effort in safety, assuring mechanism. So if the battery is almost running out, the robot is safely laying down on the floor and shutting down the operating system. And then let's see how what happened next.
Oh.
Did you already change yours?
Yeah, I changed it, but
I did that when I'm stressed out.
So I still remember the name of the boy. Yeah, so he is Tyra, and on that day when the parents came in the evening, I told the parents these things, and the parents were extremely surprised, and we had never. During his 24 months life, we had never observed this kind of thing. So this was really the first moment Tyler and saw someone who was laid down on the floor, and then purely by his own, he grabbed some blanket and put the blanket on this. So and the parents told me that they had never taught Tyler to do this kind of thing. So they were very impressed. But probably, as you can guess, that this is because the parents did the same things to Tyler. But anyway, we are very surprised that. So this is one of the example that kids that robot were really becoming a peer for them. And this yes, and this result was reported in a paper published in 2007. So again, believe it or not, so I only published one paper through this project. So by taking 3 or 4 years, and I published only one paper, including a conference paper. So Sony was very generous. Yes. But the paper, unfortunately, the paper was relatively well read. And for example, I was very happy to know that Professor Patricia Kuhl and Professor Andrew Meltsov, this is greatest psychologist in here, University of Washington. So they cited our work in their paper published in the Science, and I was very happy to know that. Right. So that was our early study we did, and this is almost the beginning of my HRI career. And then maybe this was 10 years after that, and we also did many work related with the application side, application of this robotics technology for the purpose of childhood education. And one of the work was, as Maya explained, the kind of new robot architecture, new use of robot, and we called it as a care receiving robot, because usually we position the robot as a tutor, right? So it's kind of a robot is served as a role of parents or teachers. So robots teach children, but our robot was completely the opposite. We let the kids take care of, kids teach the robot. And through the process, we can have the kids learning by teaching. So as you know, that in human education, it's always happens, right? We learn a lot from teaching others. And yes, and then after that, as I said, that in 2013 or 14, I had the opportunity to participate in this paper project, and I helped them to release this paper. And after that, the project leader and the director of this SoftBank industry and asked me to commercialize the idea of this care receiving robot. And then it was in 2014 or 2015, we developed the commercial application of this care receiving learning by teaching paradigm by using the robot. So maybe again I can show you a video. So this is a kind of a promotion video created by SoftBank.
cm 体重は 28kg です。イエーイ。よし、みんなで一緒に色で遊ぼう。では、早速、赤色ってどんな色？僕に何か赤いものを見せてもらえる？ 英語でなんて言うのですか？
They say red.
せーの、レッド。タラさん、飛行機。
So this is one of the apps utilizing the concept of this learning by teaching. So this is a English vocabulary learning application for non-native, kids. And here, this is a very simple application of the vocabulary learning of the colors. And for example, but usually, we imagine that the robot teach what red is to kids, right? So this is the most typical tutor robot. But here, the paper did totally the opposite things. So paper say that, let's take a look at it again. So how is it like a look at?
僕に何か赤いものを見せて。
Yes.
これが赤色だよね。サルさん、赤って英語でなんて言うのですか？
They say red.
So paper asks the kids to teach red. This is interesting, right? Kids is more excited to do this kind of thing. Kids are going crazy to do this kind of thing because they really like to take care of the robots. So they find a red object and they show the paper, the red ball, and the paper was programmed to gradually learn. Initially, the paper made mistake, but gradually learn the correct vocabulary. And with the help of a human teacher, so this is actually the key point. There is a human teacher and they're connected from the remotely. And that teacher clearly teaches the correct answer. So this is red. And, but anyway, with the help of a human teacher and this care receiving robot, they learn the English vocabularies more effectively. So that's a concept. So this is a commercial application, but we published more academic result in Nature conference at around, I guess, 2010 or 2012. And we reported more formal, and we conducted a formal experiment at English school, and we did this control experiments during the framework of education psychology, and confirmed the effectiveness. And then SoftBank asked me to commercialize the concept, and this apps was released. Okay, so anyway, this is a educational app. And I guess we also did a kind of this telerobotics, the use of telerobotics for the purpose of education. I think you can imagine that. So we just created this avatar robot and utilized it for the purpose of education. So this was, again, 10 years ago. But we did this real field studies of connecting two classrooms between Australia and Japan, and we put avatar robots in both classrooms, and kids in Australia participated in the Japanese classroom through controlling the avatar robots. Okay. Anyway, so it was around 2017 or 18. I felt that I think I'm done with this educational robot research. So we summarized our work, and we wrote a paper to the Science Robotics in 2018. And then, fortunately, the OECD found this paper and asked us including, for example, Tony Belpame. Tony Belpame is also our colleagues in working in the field of HRI and education robots. And Tony and I participated in publishing this white paper on the OECD to claim the future of digital education, including AI, blockchain at that time, and robots. Okay, so that was almost our old work. And then lastly, and I would like to talk about a more recent project after 2020. And one of the projects we have been working in the last 5 or 6 years is to support the elderly people. As you know, that Japan is a super aging society with extremely fewer kids, so this is a very severe problem. So, and we want to utilize social robots to prevent, for example, the social isolation among older people, and particularly who lives alone. And one of the concepts we have been proposing in the last 5 or 6 years is this social mediator robot. Let's use the robot as a mediator connecting humans. So for example, this robot is now serving as a mediator connecting between, for example, me and my daughter, who lives remotely. And but you know, and this is an important point. Actually, sometimes, and it is not easy for us, older people, to self-disclose some serious issues, even towards families. For example, the financial topics or health-related issues. But of course, from the perspective of the family, we really need to identify the issues as early as possible and to support that, right? So it's very practically important to facilitate the self-disclosure of the elderly persons, and then anyway, with the help of these robots to facilitate the communications in general. So this is the concept of a social mediator robot. And before that, I think it was 2018 or 19, we did an exploratory study, and we found that actually the social robot can be an active, effective mediator who encourages those people to disclose their problems. So in this preliminary studies, so we compared the use of standard phone and text messaging and this social mediator robot and non-expressive mediator robot. And of course, because this is a preliminary study, we had a small number of samples, but we had an impression that actually, if we measure the ease of self-disclosure, so elderly people prefer this social mediator robot than standard text or the non-expressive robot. So that's why I had an impression that robot could serve as a nice mediator to for elderly people to disclose some serious topics. And then we did more formal studies. We put resource on this project, and then we did more detailed studies and studying those research questions. So this is a typical HRI study. And yes, so in this first study, we studied these two research questions. Research question number one, in what topics can the robot encourage elderly self-disclosure because it's depending on the topics, right? We want to know the topics. And then number two, how the robot's personality, character, for example, the way of speaking, and those characters should be personalized to the character of the elderly persons. So to identify, to have the design guideline to answer to these research questions, so we conducted a survey, online survey, and in this study, yes, 720 older people in Japan, and we asked several questionnaires, and then also we asked the personality traits of each elderly persons, and also we showed the videos of the robot prepared in the couple of personalities. Probably HE means the high extroversion, and HN means high neuroticism. Maybe you HRI, people are very familiar with this concept, but usually the human personalities can be summarized. For example, there's two dimensions like extroversion and neuroticism. So you can divide the human personality in this 4 dimension, high extroversion, high neuroticism, to low extroversion, low neuroticism. And also we create a robot way of speaking in high extroversion or low neuroticism, and create a video and then show it to the 720 elderly participants, and then ask the how do you feel? Which one do you feel the most easy to self-disclose, or those kind of things? And then this is the results. So we compiled those data, and we found those design guidelines. So now we have that based on the topics and the user personality traits. We have the recommended personality traits for social mediator robot. So for example, topics, if the topic is health-related topics, and if the elderly person is a high extroversion and high neuroticism, the robot should be designed in a way like having low neuroticism. So this kind of thing. So we have now the design guideline of this effective personality traits for social media. I think this is the first study we published in 2020. Okay, and then after that, and we also have a couple of more detailed HRI studies, but today I skipped those kind of things, and now I will going to show you a bit different approaches. So we also were interested in these nonverbal channels. So let's just imagine that this is a future cell phone. And maybe first I again show you a video first. Okay. By the way, how long can I talk? Until maybe
5 more minutes.
5 more minutes, okay. Then I will just quickly show you. So this robot has an internal weight shifting mechanisms. So inside this body, there is this tungsten weight moving on the 2 arbitrary two-dimensional space. And then as a result, by letting the internal weight moves, the users can feel a certain amount of feeling, such like emotion or intention from the robot. So this is clearly different from the typical vibration of a cell phone. It's more vivid. So, and then, we can design several weight shifting moving patterns, and yes, it's a so somehow I cannot see, but if you want to express the semantics meaning like refusal, urgency, or joy, and the robot should move like that. So we after conducting a study and analyzing data, we have these design guidelines. So anyway, then right. So again, we envision creating this kind of idea for the purpose of a social mediator robot. So, for example, the one day this person, my daughter sent a text message asking me that, how are you, Dad? And then I answered, I'm okay. But to be honest, I had some knee troubles or something like that. I'm okay. But if we augment this text message with this kinds of non-verbal, motion, and showing that actually that is, that condition is not good, and then this side, the receiver can feel that something wrong is happening, and then my daughter resends the next text message saying, "Hey, Dad, are you really okay?" And then I just, to tell the truth, I had a trouble or something like that. So anyway, so the idea here is that by augmenting the text message with more, subtle but effective non-verbal expressions, we can enhance or help the human communications. So this is the idea of this physical social mediator robot. And in fact, we also, after that, we had this three-dimensional versions as well, and it was presented at ICRA a couple of years ago. So here we can arbitrarily program the weight movement in three-dimensional space. Maybe I just, due to the time restriction, I have to skip this part. Anyway, so those are the researches I wanted to show as an example of a social mediator robot. And then also recently we have been doing a bunch of researches related with this, social robots. And but mainly, as I said, that we want to help these aging societies, and we want to alleviate the psychological loneliness, or those negative human feeling with the help of social robots. And there are many approaches. So one approach is this a robot which can change the temperature, surface temperature. So we physically we can create a warm robot, or in the reverse. So we just create a robot and whose temperature can be arbitrarily controlled. And also, we also did some soft robotics studies about this variable softness. The robots can hard, but if you interact with the robot a lot, the robot can become more soft. This kind of things. We utilize this thermal responsive gel, and to change the softness of the robot. And maybe this I will. At the last, I will show you another video. This is also the soft robotics research we did recently. Maybe I just stop. But as you can see, that this is a airbag-based soft robots, and after some prototyping, we ended up using 3 chambers, 3 airbags. But simply the idea is that if the robot clench the robot clench the grasp you back. And also, we can control this interaction of the timing in an arbitrary way. And through this dual haptic grasp or clenching interaction, we just realized that surprisingly, human perception of pain is alleviated. It's a kind of a distraction, but we scientifically confirmed through the experiments of 80 participants with the framework of these thermal pain stimulations. And this is just a summary of the results. The subjective pain ratings decrease. And also we measure this salivary oxytocin and cortisol, and which is known to correlate with the stress, psychological stress. And also the fear of injections. I personally dislike injections, so this is very important. Right. So originally, we intended to create this for kids, so not for me. But you know, kids can bring this Baymax-like robot to hospitals. And during the vaccinations, they cringe, and then down. I don't feel anything, or something like this. Yes. So that's the idea of this. The wearable soft robot, and alleviate the pain and the fear of the wearer. Okay. So if you are interested in, I also can show you this robot head mounting, but maybe due to the time, I will skip at this one. Yes. Okay. So anyway, so recently I have been working in the field of these social robots, and to help people from aging, societies, particularly the psychological loneliness or those kind of things, and try to contribute keep maintaining their quality of life. Okay, so that's all about my research part. So just in conclusion, so to wrap up, so as I tried to explain to you in the beginning of the part of today's talk, So we at the University of Tsukuba also have robotics faculties doing their research. So if, as I have repeatedly saying that if there are some point which somehow hit your interest, just don't hesitate and contacting me. So you can just search my name and you will easily find my email address, but my email address is here. Okay, so that's my talk, and thanks for listening.